You know, in the world of AI, it feels like the motto is always bigger is better. But what if the secret to a truly smarter AI isn't about building one single giant brain, but creating an entire team of them? Today, we're diving into a really cool new paper from Meta that does exactly that. They've built a system that's not just cheaper, but, and this is the wild part, it's actually more effective too.
And that really is the question facing AI developers right now, isn't it? We all know these huge models can do some incredible things, but man, they come with a massive price tag to run. So are we just stuck choosing between raw power and something we can actually afford? Or is there maybe a third option?
So the idea of using small, nimble AI agents is really appealing. And when we talk about agents, all we really mean is an individual AI program that's good at certain kinds of tasks. The little ones are cheap and super efficient for simple jobs. But the big question has always been, can they handle the really tough stuff? Well, as you're about to see, when things get complicated, these small agents tend to hit a very hard wall. So here's the classic dilemma, right? On one hand, you've got your small, cheap agents. Think of them as your eager, affordable interns. And on the other hand, you've got the large, powerful agents, your super expensive senior consultants. Now, you can't afford to hire that top consultant for every little thing, but you also know the intern might be in way over their head on the big, important projects. And wow, this graph just lays it all out there, plain as day. Over on the left, where the tasks are simple, you can see that all the models are performing pretty well. They're all kind of bunched together. But look what happens as you move to the right and the tasks get harder. Those bottom lines, the smaller agents, their performance just falls off a cliff. They simply can't keep up. So the real trick is, how do you get the best of both worlds? And this is where Meta's idea gets really cool. They asked, what if you stopped thinking about hiring just one AI and instead you built a whole marketplace, a kind of digital gig economy, where all these different AI agents could compete for your work, just like freelancers on Upwork or Fiverr. I mean, just picture it. You've got this whole team of digital workers ready to go. You've got your junior agent on the left, cheap, but maybe not as experienced, and you go all the way up to your pricey, powerful expert on the right. Now, when a new task comes in, who do you hire?
So the fancy name for this whole system is SAIL, which stands for Strategy Auctions for Workload Efficiency. And honestly, that's a perfect description. It's basically an automated auction house that takes bids from all these different AIs and then picks the absolute best one for the job by weighing both how much it's going to cost and how good a job it's likely to do.
Okay, so how does this whole AI auction house actually work? Well, it's a really clever four-step process that's designed to be super efficient. Let's break it down.
It all starts with bidding. Then, those bids get scored. After that, a winner is selected. And then, and this is my favorite part, the other agents get a chance to learn and refine their approach for the next time. Let's walk through each one.
Now, what's so smart about this first step is that the AI agents don't actually have to do the whole task to place a bid. I mean, that would be incredibly slow and expensive. Instead, each one just writes up a quick plan of attack, a short proposal that basically says, hey, here's how I would tackle this problem. That little plan, that's their bid.
Next up is scoring the bids. And every bid is judged on two key things. The first is predicted cost. That's pretty straightforward. But the second part, predicting the value, that's where things get really clever. The system basically puts together a jury of all the other AI agents to read each plan and rate how good it is. It's like an instant, automated AI peer review. So you've got the cost, you've got the value score, now what? Well, the system chooses a provisional winner. And it's not just picking the cheapest one, or even the one with the highest quality score. Nope, it awards the job to the agent that offers the best overall trade-off, the most value for the least cost, the best bang for your buck.
But wait a second. What if a cheaper agent just happened to submit a slightly worse plan, but it could have done a better job if it just had one more chance? This is where the whole system gets really smart.
This final step is like the system's secret weapon, refinement and learning. See, any agent that's cheaper than the current winner gets a second shot. They get to look at a shared memory bank of strategies that have won or lost on similar tasks in the past. They actually learn from what worked before, tweak their plan, and resubmit their bid. It's basically a built-in training program that helps the cheaper AIs get smarter over time. It's brilliant.
So that's the theory. It's this super sophisticated marketplace of AIs that are competing and learning from each other. But okay, does all this fancy auction stuff actually work? I mean, is it really cheaper, faster, and maybe, just maybe, even better? Well, the results are kind of wild.
All right, first up, the big one, cost. Compared to just throwing the best, most expensive AI model at every single problem, the sales system slashed costs by an average of 35%. That's not a small chunk of change. That is a massive saving.
And how did it pull that off? Well, look at this. The system cut its reliance on that top-tier, priciest model by more than half. It actually learned how to successfully delegate the huge majority of its work to the cheaper, more efficient members of its team.
Okay, but this next one, this is the one that really blew my mind. The sales system wasn't just cheaper, it was more accurate. That's right, by intelligently picking the right agent for the right job, the team as a whole was actually 3.5% more successful than even its smartest, most powerful individual agent. This chart just brings it all home. See all those red dots? Each one is a single AI model. And you can see the general trend. As you go right, they get more expensive. And as you go up, they get more accurate. But then, you see that blue star way up there in the top left? That's our sales system. It is pushed into this incredible new zone, achieving higher performance than even the best model, but at a way, way lower cost.
So, what's the big takeaway here? This really suggests a huge shift in how we should be thinking about building AI. Maybe the goal isn't to build one single giant know-it-all AI.
You know, the researchers themselves say it best. They think the next big leaps in AI might not come from building bigger and bigger models, but from getting better at coordinating them. From building these smart, adaptive ecosystems where lots of different AIs, big and small, can work together. It's about building a great team, not just trying to find one single star player.
Which leaves us with this one last kind of mind-bending thought. Could this be what the future of using AI is actually going to look like? Imagine, every time you ask your phone a question, it kicks off this lightning-fast, invisible auction in the background with dozens of AIs all competing to give you the best possible answer for the lowest price. It sounds like science fiction, but after this, it doesn't seem so far-fetched anymore.